So I'm just going to say a few words about the background to the meeting. So the precision of radial velocity surveys has been increasing in an extraordinary fashion over the last 30 years, but 3 or 4 years ago when I made this slide, we were really starting to see the effects of a stellar activity flow that was preventing detections of low amplitude and longer period planets. And to address this, many of us have been working very hard over the last few years, and we still, although we're making a lot of progress, we're hoping that meetings like this one will catalyze even more progress. So in my group in Oxford, we've been developing methods which exploit the relationship between different observables related to stellar activity, including photometry and more recently spectroscopic activity indicators. I won't go through the details of this, but essentially it relies on noticing these correspondences and then trying to implement them in data-driven models, which implement them as flexibly as possible, because we don't think we can model them in sufficient details from first principles. And so 7 years ago now, that's a bit scary, we developed this multidimensional Gaussian process framework with my former student Vinesh Rajpal, who is hopefully joining us online some of the time. And we have been applying this and trying to test it further and develop it further. And this is just one of many methods to model activity signals in radio velocities that work primarily in the time domain. And since we published this paper, of course, many other people have then improved on it, both scientifically and computationally. And in parallel with that, there's been also a lot of progress in working on the spectra, extracting less activity sensitive or deliberately more activity sensitive radio velocities, and modeling the variations in the shapes of the spectral lines, which are caused by activity. And we'll talk about all of this during the next 3 days. So part of what I hope this workshop might achieve is bringing some of these techniques together, initiating collaborations so that we can get ideas, test them, and work further. So in Oxford, with the group working on this is funded mainly by this grant from the European Research Council that started about a year ago and it's got about 4 years to run. And we are working both analyzing large archival data sets from HARPS and HARPS North, and we're also preparing for the Terra hunting experiment, which will use HARPS 3, a copy of HARPS and HARPS North, to be installed on the 2.5 meter Isaac Newton telescope. And we have the HARPS 3 and Terra hunting instrument scientists in the room with Sam. Yes. Hi. So the current team members, you've already met all of them. So Oscar, Baptiste, and Houtran, and we're also excited to be joined next year by Michael, who's also in the room, and Niamh O'Sullivan is a new PhD student who will start in October. So I'm just going to end with my last word, which is that I hope there'll be another of these workshops in a couple of years, in a few years maybe. And I also hope that we'll have other workshops organized by other groups elsewhere. I think this is an area where we still actually trying lots of new things, so we need to talk to each other often in order to make progress happen. I'm just going to check. Yeah, that's it. These are all holding slides. So I'm going to stop sharing my slides, and Oscar is going to move. Okay.